your thought process must be refined, right? That is what is physics. So if I say if you usually used to say when the body is in motion, you used to say the body is moving. Now you should say the body is in motion. Okay? What do you mean motion? Well, the moment I say body is in motion, then you must locate the body in space. So it would occupy some position P1, okay, with respect to some reference point. It would have occupied the position P1 and you would have located the body. See, that means now your observation starts. You say a body is in motion means, say, assume that you have closed your eyes, suddenly you open your eyes and you will find the body here. It is moving. So when you open your eyes, it is here and it is moving. So you have found the body is here, and the moment you open your eyes, the time is T1. Okay, and then you see, then what you do immediately to this body, right? You will associate a velocity vector, right? That is precisely what you do, right? There afterwards, you will follow the instructions. Okay, what are the instructions? That you have to wait. Okay, now you see that the moment you see the body, it is at time T1. Time is ticking. Means what? Time is advancing. 1 second, 2 seconds, 3 seconds, 11, 12, 13. It will not stop. In this world, you cannot stop time. Right? That is not under your control. The moment we are born, time starts ticking for us. Got it? So the time is ticking. So now if I tell you from time T1 to time T2, okay, well, I am not applying any force. Then that implies what? Look, fast answer. That is, I am not applying any force. Means what?
The state of motion will not change.
Fatapat you should tell. State of motion will not change. State of motion will not change means what? Fatapat.
Velocity vector will not change.
Velocity vector will not change. Beautiful answer. Velocity vector will not change. The body is moving in uniform velocity. Immediate consumption. Right? So the body is moving in uniform velocity. Okay. So at the time from T2 to T3, if I apply force, okay, F bar, then what happens?
The body will accelerate.
The body will accelerate. Means what?
The force acts on.
Means what? What is the consequence? So it accelerates. See, force acts, it accelerates. Consequence of acceleration, its consequence of acceleration, what? Loud.
Increase of speed.
Consequence of acceleration is increase of speed. Got it?
Yes, sir.
Only increase of speed. Only increase of speed. So you are wrong again. You are wrong. You are not imagining. You are simply, barking answers. What did I teach you yesterday? Well, the body is in motion. Its velocity vector is like this. If force acts on the body, what happens? So force can act like this also. Force can act like this also. No. If force acts like this, velocity will increase. If force acts like this, speed will decrease. No, then why did you say only increase? So this is not learning. See, you have to connect yourself to the reality, man. You should not answer like this. Don't think it is so simple. Yesterday you asked, I am very intelligent, I will answer. I will twist the question. You should be prepared for it. Got it? Hello, are you ready?
Yes, sir.
So when force acts, what happens? Fatapat.
Velocity will change.
First it accelerates, man. See, you go in step. Force acts on a body, it accelerates. What happens because the body is getting accelerated?
The velocity changes.
Velocity vector changes. Got it?
Yes, sir.
Now, if I tell you, we are discussing one-dimensional motion. One-dimensional motion means what?
Straight.
The body is set to move along straight line, like this or like this. Then only the speed will increase or decrease. Got it?
Yes, sir.
Speed will increase or decrease. Correct? Now imagine a condition. Can you imagine a body? See, now on the football ground, you see a football, you kick a football. Hello? You
Yes,
kick
sir.
a football. So now you imagine a football field, right? So you have got a huge football field. Huge football field. Okay? Right. So you are here, right? Right? Then you are going to kick the football. You are going to kick the football. The moment you kick the football, what happens to the football?
Accelerated.
Loud! It accelerates. Hey, state of motion Artika Mundin it accelerates. The moment you kick the ball, it accelerates. The moment you kick the ball, it will accelerate. Now, the moment you kick the ball, it accelerates. Afterwards, what happens?
Change of velocity.
The moment you kick the ball, it accelerates. That means at that point, the velocity has changed. Afterwards, what happens?
So it will move in a uniform velocity.
No, you correct. Very good. It will start moving at uniform velocity. See, you are not imagining when you kick the ball, that moment it has accelerated. Afterwards, you are not kicking, no. In kal ishta vadite tho, ame vadgotirtite na. Football adile ನೀವು ನೋಡಿ ಇದು ಕಾಮನ್ ಸೆನ್ಸ್ ಬೇಕು ಫಿಸಿಕ್ಸ್ ಕಲಿಲಿಕ್ಕೆ. You kicked the football, at that moment it accelerated. Got it? Afterwards you are not touching the ball. Understood? So the body starts accelerating. The body starts moving in uniform velocity. Correct now? Hello? So from this point a velocity vector is there. Up to this point the velocity vector continues. Got it? You have seen football now? So the football is now moving. Okay? Right. Now I will show you by another nice figure. So you have kicked the football, right? So there is a football. There is a football, and you have kicked it. So the moment you kick it, it will have some velocity vector v bar, and it continues to move. Here also there is velocity vector v bar. Correct? Hello?
Yes, sir.
Yes, sir.
So it continue with the same velocity. Hello?
Yes, sir.
Yes, sir.
Now, here you see. Here, there is one more person. Football field you have seen?
Yes, sir.
There is one more person. So he will kick the football like this. Hello? Got it?
Yes,
So
Yes, sir.
at the moment he kicked the football, the velocity vector was like this. Now when he kicks this, what does he do? What does this person do? Hey, what does this fellow do? What does this fellow do? You should tell like that. See, you should tell. He will apply force in this direction. Got it?
Yes, sir.
Now what happens? He will apply force in this direction. What happens? You go in steps. He will apply force. As a consequence of force, what happens? As a consequence of force, what happens? See,
Sir, the body accelerates.
after you see simple steps, sir. The moment he kicks the ball, the body will accelerate. See here, the acceleration vector is in this direction.
Yes, sir.
Okay? Now come to reality. You have played football? You have played? All of you?
Yes.
So one person kicks. Another person will come running and he will kick. Right? Now what happens? In the field, what happens? In the field, what happens? The ball was going like this. Another person kicked. Then what happens?
Sir, the direction of football is.
Direction of football will change now. Got it now?
Yes, sir.
Hello, understood now?
Yes,
sir.
So now the football will deviate like this and start moving like this. Got it now?
Yes, sir.
So here you see, what did the force do? Force accelerated. What do you mean by acceleration? It will change the velocity vector. Now in what way did it change the velocity vector here? Direction has changed. Speed might have changed. We don't know. Speed can also change. Direction also changed. So the force here changed the velocity vector. Change the velocity vector in this case means it has changed the direction and probably it would have changed the speed also. One thing is sure, the direction has changed. Why the direction has changed? Force was applied in? Tell. This direction means what? See, if the force was applied in this direction means what? You see, the velocity vector was like this. If the force vector is also applied like this, which called it is collinear. Velocity vector was like this, force vector was also like this. Then direction will not change. Only the speed will change. Now velocity vector is like this, force vector is like this. Now the direction of the velocity vector will definitely change. Speed, whether it changes or not, we will see later. Got it?
Yes, sir.
Now this is the reality. So therefore now when I say linear motion, then If I say it is linear motion, if I say it is one dimension motion, and if I say a body is moving with velocity v, and if I say the force is acting on the body, then its velocity changes. But since I told it is linear motion, means velocity changes means what? Speed has changed. Direction will not change. Got it?
Yes, sir.
Hello?
Yes, sir.
Yes, sir.
Yes, sir.
But direction will also change. Means what? See, for example, the body is moving like this. Velocity vector is like this. If the force vector is like this, what happens?
Sir, the speed decreases.
The speed will decrease. Got it?
Yes, sir.
And then what happens?
Yes, sir.
Speed will decrease. Then what happens? Well, what will happen? If I go on applying this force, what will happen? Common sense.
Sir, it will move in that direction.
So first, first what will happen here? See, now imagine, your cycle is going. Your friend will start pulling the cycle. So what happens? The speed of the cycle goes on decreasing.
Yes, sir.
Ultimately, the cycle will stop. Ultimately, the velocity will become zero. Why? The force is acting like this. Then what happens? If your friend continues to pull, then the cycle will start moving in opposite direction.
Yes, sir.
But it is confined to straight line motion. Are you able to connect all this?
Yes, sir.
So now, therefore now, if you say it is linear motion, and if force acts on the body, what happens? Tell by steps. What happens if the force acts on a body?
Speed will decrease.
It's a
Speed will decrease.
no, ma. See, I told force will act on the body. So I should say the force can also act like this. Did I say force is acting in opposite direction? Did I say, Harshita? I didn't say no. So you see, this is what you have to now get trained. You should all get trained now. You should now become very, very alert students. Your mind should be completely imagining things. The body is moving. Immediately see the velocity vector. Force is applied to the body. I say the body is in motion, velocity vector, and I say it is linear motion. That means you will draw a straight line. And then I say force is applied to the body. Then immediately your mind should think force can be like this also, like this also. So what happens in linear the body is one dimensional motion. The body is in motion. So you see the velocity vector. Then I say force is applied to the body. Allah, force is applied to the body. When I put the bracket linear motion, that means what? You'll imagine the force like this or like this. Got it?
Yes.
So immediate answer is it will accelerate. Acceleration ಅಂದ್ರೆ ಬರೀ speed increase ಆಗೋದಿಲ್ಲ. Positive acceleration. If the force vector and velocity vector are in this direction, then also we say it is acceleration. If the velocity vector like this, force vector like this, then also we say it is acceleration. Got it?
Yes.
But only thing is, in this case the acceleration is positive. In this case the acceleration is negative. Correct?
Yes.
So positive acceleration will increase the speed. Negative acceleration will decrease the speed. Correct? Understood all of you? This is only reality. ನಿಮ್ಗೆ ಗೊತ್ತದೆ. ಅದನ್ನ ನೀವು ಸ್ವಲ್ಪ ಫಿಸಿಕ್ಸ್ ಲ್ಯಾಂಗ್ವೇಜ್ ನ ಕೇಳಾಕತ್ತೀರಿ ಅಷ್ಟೇ. This is one dimensional motion. Now if I remove the word one dimensional motion, if I remove the word one dimensional motion and say the body is in motion, then what will you do? What will you do? If I say the body is in motion, same thing, man. You will see the body and attach a velocity vector. Hello?
Yes, sir.
One dimensional motion andre you will draw a line. The body is moving like this, up and this. If I remove the word one dimensional motion means what? The body can move in any direction.
Yes, sir.
So when I tell you a body is in motion, whether it is one dimension or two dimension, you will draw a velocity vector. Over. One dimension and two dimension, this is also common. Body is in motion andre body very big. This has got mass m, it has got velocity vector. Bharat Gudbe. Now if I say one dimension means it is restricted to this line. If I don't say it is one dimension, it can go in any direction. In football field, you will say one dimension motion.
No, sir.
It can go anywhere. Isn't it? It can go anywhere. Understood? So that is the reality. No. I used to teach one dimensional motion because sun huduguru starting. one dimension motion is easy to understand. So I was teaching. Now please appreciate and understand the real motion can be 2 dimension, it can be 3 dimension. 2 dimension means what? It can move anywhere on the field, on the ground.
Yes,
Football can move anywhere on the ground. This is 2 dimensional motion. 1 dimension means it will only move in straight line.
Yes, sir.
2 dimension means
It
it can move anywhere on the ground. 3 dimension means the ball can go like this, down, kick ಮಾಡಿದ ಮೇಲೆ ಬರ್ತೈತಲ್ಲ. Understood?
Yes, sir.
Understood? That becomes what? 2 dimension, 3 dimension motion. Anyway, we will go into 3 dimension on later. So first, you understood 2 dimension, 1 dimension now?
Yes, sir.
Yes,
Huh.
sir.
So now tell me, if I don't use the word 1 dimension motion, then means if I use the word 1 dimension means what will you do? If I use the word 1 dimension, what will come to your head? What will come to your head if I say 1 dimension?
So straight line.
Ah, very good, beautiful, very good. So you say 1 dimension, immediately draw a straight line.
Yes, sir.
ತಲೆ ಒಳಗೆ. Then if I say body is in motion, then immediately ನೀವು ಒಂದು ಪಾಯಿಂಟ್ ತೆಗಿಬೇಕು, ಅದಕ್ಕೊಂದು ವೆಲಾಸಿಟಿ ವೆಕ್ಟರ್ ಹಾಕಿ.
Yes, sir.
ಲೀನಿಯರ್ ಮೋಷನ್ 1 ಡೈಮೆನ್ಷನ್ ಕೂಡ ಒಂದು ಗಿರಿ ಹೊಡಿಬೇಕು. ಬಾಡಿ ಇಸ್ ಇನ್ ಮೋಷನ್ ಅಂದ್ಕೊಳ್ಳೆ ಒಂದು ಪಾಯಿಂಟ್ ತೆಗಿಬೇಕು, ಅದರ ಮಾಸ್ m ಅನ್ಬೇಕು, ವೆಲಾಸಿಟಿ ವೆಕ್ಟರ್ v1 ಹಚ್ಚಬೇಕು. ಮುಂದೆ ಹೇಳಿ ಸರ್ ಮುಂದೆ. ಫ್ರಮ್ ಟೈಮ್ t1 to t2 so and so, from t2 it is so and so ಹೇಳ್ಕೊಂತಿದ್ದಂಗೆ ನೀವು ಅವ್ರು ಏನೇನು ಕೇಳ್ತಾರೋ ಅದ್ರ ಪ್ರಕಾರ ನೀವು ಏನೇನು ಆಗ್ತದೆ ಹೇಳ್ಕೊಂತ ಹೋಗ್ಬೇಕು.
Yes, sir.
Yes, sir.
ತಿಳಿದಲ್ಲ? ಅಷ್ಟೇ ಜೀವನ ಅಷ್ಟೇ. ಈಗ ನಾನು ಸಪೋಸಿಂಗ್ ಏನು ಹೊಡೆದಿಲ್ಪ, ಎ ಬಾಡಿ ಈಸ್ ಇನ್ ಮೋಷನ್ ಅಂದ್ಬಿಟ್ಲೆ ಏನು ಮಾಡ್ತೀರಿ, ಗೆರಿ ಹೊಡಿಬಾರ್ದು. ಒಂದು ಲೈನ್ ಯಾವಾಗ ತೆಗಿತೀರಿ, ಲೀನಿಯರ್ ಮೋಷನ್. ಇಲ್ಲಿಕ್ರ ಡೋಂಟ್ ಡ್ರಾ ದ ಲೈನ್. ಗಾಟ್ ಇಟ್?
Yes,
So if I say body is in motion, then simply take a point, mass m, the body is in motion. Linear motion ಅಂದ್ರೆ ಗೆರಿ ಹೊಡಿ. ತಿಳಿದಲ್ಲ?
Yes, sir.
Yes, sir.
ಈಗ ಫೋರ್ಸ್ ಆಕ್ಟ್ಸ್ ಆನ್ ದ ಬಾಡಿ. ಇಲ್ಲಿ ಫೋರ್ಸ್ ಆಕ್ಟ್ಸ್ ಅಂದಾಗ ಏನ್ ಮಾಡ್ತೀರಿ? ಇಲ್ಲಿ ಫೋರ್ಸ್ ಆಕ್ಟ್ಸ್ ಅಂದಾಗ ಏನ್ ಮಾಡ್ತೀರಿ? ಎಫ್ ಬಾರ್, ಬರೇ ಎಫ್ ಬಾರ್ ಅಲ್ಲೋ ಏನ್ ಮಾಡ್ತಿ?
Sir, ಈ ಕಡೆ ನಾನು ಈ ಕಡೆ force.
ಅಂದ್ರೆ ವಾಟ್ ಯು ವಿಲ್ ಸೇ, ಸರ್ ಡ್ರಾ ದ ಫೋರ್ಸ್ ವೆಕ್ಟರ್ ಅಲಾಂಗ್ ದ ಲೈನ್.
Yes, sir.
ನೋಡಮ್ಮ, ಸತ್ಯ ಹೇಳ್ಕಮ್ಮ, ನೀ ಬರೇ ಫೋರ್ಸ್ ವೆಕ್ಟರ್ ತೆಗಿ ಅಂದ್ರೆ ನಾನು ಹೆಂಗ್ ಬೇಕಾದ್ರೆ ತೆಗಿತೀನಿ, ಹಿಂಗೂ ತೆಗಿತೀನಿ. ಹೌದಿಲ್ಲ? ಸಂಪೂರ್ಣ ಸತ್ಯ ಮಾತಾಡ್ಬೇಕು, ಹೌದಿಲ್ಲ? ನೋಡ್ರಿ, ನೀವು ಸಂಪೂರ್ಣ ಸತ್ಯ ಮಾತಾಡೋದು ಕಲೀರಿ, ನಿಮ್ದು ವ್ಯಾಲ್ಯೂ ಇನ್ ದ ಸೊಸೈಟಿ ವಿಲ್ ಇನ್ಕ್ರೀಸ್, ಪೀಪಲ್ ವಿಲ್ ರೆಸ್ಪೆಕ್ಟ್ ಯು, ಯು ವಿಲ್ ಗೆಟ್ ವೆರಿ ಗುಡ್ ಜಾಬ್, ಪೀಪಲ್ ಆರ್ ವಾಚಿಂಗ್ ಯು. Understand? You refine. So if I say a force is applied on this body, then immediately you will tell, sir, you draw a force vector along this line, either in this direction or this direction. Got it?
Yes, sir.
Here if I say the force is going to act on the body, what will you do? It can be in any direction. Then you will ask, sir, in which direction? Here, sir, it is here. If I tell you force is acting on the body, what will the question you will ask? Sir, is it along the velocity vector or opposite the velocity? You should ask, right? So, if I tell you force is acting on the body, what will you ask?
So, is it along the
It is along the direction of velocity vector or opposite? Only 2 options.
Yes, sir.
Got it? Now here, I'll tell you force is acting on the body. What is the question you will ask? Think.
So, in which direction?
Very good. So, in which direction is the force applied?
Yes, sir.
Okay. So, I will tell, so force is applied in this direction. It makes an angle 45 degrees with the velocity. Got it?
Yes,
Yes,
sir.
sir.
Understood all of you?
Yes, sir.
Hello?
Yes, sir.
Yes, sir.
Now, Alex, the body is now, understood now? If I tell you in what direction, it will show like this. Hello?
Yes,
Yes,
sir.
sir.
Okay. ಈಗ ನಿಮ್ಗೆ ಜಾಂಟ್ ಅಂದ್ರೆ ಒಂದು ಕ್ವಶನ್ ಕೇಳ್ತೀನಿ, ನೀವು ಆನ್ಸರ್ ಮಾಡ್ತೀರಿ?
Yes, sir.
ಈಗ ಈ ಬಾಡಿಗೆ if I tell the force is applied along this line, what will happen? If I say in this case the force is applied, that means you will apply the force along that line. Then what is the consequence? ಅರೆ ಏನಾಗಿದೆ ಮತ್ತೆ ಹೇಳಲ್ಲ, ಸ್ಪೀಡ್ ವಿಲ್ ಬರೇ ಇನ್ಕ್ರೀಸ್ ಯಾಕ?
So, it will accelerate.
No, speed will either increase or decrease.
So, you told in this direction.
I didn't say. I said, sorry. I think I said it wrong. Sorry. So if I tell you force is applied here, then only two things can happen. Either speed will increase or decrease. Only two things will happen, correct? No, nothing more than this. Hello?
Yes, sir.
So you see, you should see the whole idea is, you should tell such a word that it will give you maximum meaning, maximum truth. Okay, velocity vector will change, motion will change, correct? It is more general. It is more general. See, now if you know him, who is he? So you know he is Vijay, you can tell so many things about him. He is in this school, he is in this batch, etc. But when you don't know him, you will simply say he is a person. So when you know more, you should tell everything. Then more truth you will tell. That is all. Nothing great about physics. So in this case, if I say it is linear motion and force acts on the body, only two things happen. What are the two things? Either speed will increase or decrease. Now, understood? Now, in this case, when I say a body is in motion, okay? Now, if I say force acts on this, then what are all the consequences? What will happen if force acts on the body?
So speed increase or decrease?
So speed will change. Speed will change.
Yes.
So best thing is speed will change. Is that the better answer? Speed will change means increase or decrease. So speed will change, right?
So direction.
Direction.
So second thing is direction will change. Next. What is the third consequence? Hello. Nangola, ಏನಾಗ್ತದ ಥರ್ಡ್ ಏನ?
Velocity vector.
ಈಗ ಸ್ಪೀಡ್ ಚೇಂಜ್ ಅಂದ್ರೆ ವೆಲಾಸಿಟಿ ಚೇಂಜ್, ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ವೆಲಾಸಿಟಿ ಚೇಂಜ್. ಮೂರನೇದು ಏನು ಕಾನ್ಸಿಕ್ವೆನ್ಸ್? ಒಂದ ಸ್ಪೀಡ್ ವಿಲ್ ಚೇಂಜ್, ಒಂದ ಡೈರೆಕ್ಷನ್ ವಿಲ್ ಚೇಂಜ್. ಇನ್ನೊಂದು ಏನಾಗ್ತೈತಿ ಸ್ಪೀಡ್ ಫೋರ್ಸ್ ಅಪ್ಲೈ?
It will accelerate.
ಸ್ಪೀಡ್ ಚೇಂಜ್ ಆದ್ರ, ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಆದ್ರ, ವೆಲಾಸಿಟಿ ಚೇಂಜ್ ಆದ್ರ ಆಕ್ಸಲರೇಟರ್. ಹಳೆ ಅಲ ಮಗಳ ಗಂಡ ತಿಳಿದೆ? ಹಲೋ, ಈಗ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಆದ್ರೆ ಆಕ್ಸಲರೇಟ್ ಆತ. ಆಕ್ಸಲರೇಟ್ ಆದ್ರಪ್ಪ ಸ್ಪೀಡ್ ಆರ್ ಚೇಂಜ್ ಆತ, ಡೈರೆಕ್ಷನ್ ಆರ್ ಚೇಂಜ್ ಆತ. ಇನ್ನೊಂದೇನು ಆಪ್ಷನ್ ಅದ? ಒಂದ್ ಏನಂದ್ರೆ ಸ್ಪೀಡ್ ಚೇಂಜ್ ಆಗ್ತೈತಿ, ಇನ್ನೊಂದ್ ಏನಂದ್ರೆ ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಆಗ್ತೈತಿ, ಮತ್ತೊಂದ್ ಏನದ ಆಪ್ಷನ್? ಎರಡು ಬೋತ್ ವಿಲ್ ಚೇಂಜ್. ನೋಡು ಋತ್ವಿಕ್, ನೋಡ ಅವಲಕ್ಕಿ ತಿಂದು ನೋಡಿ ಹೆಂಗಾಗ ಈಗ ಮಸ್ತ್ ಆನ್ಸರ್ ಮಾಡಾಕತ್ತಾನ. ಗುಡ್
So what was
ಋತ್ವಿಕ್.
the answer?
He said both can change. Direction also can change, speed can also change. Hello, ಹೌದಿಲ್ಲ? ಇದಕ್ಕೆ ಏನ್ ನೈನ್ ಕಲಿಸ್ಬೇಕಾದ್ರೆ ಈ ಫೋರ್ಸ್ ಆಕ್ಟ್ಸ್, ಒನ್ is speed will change or direction will change or both will change. ಹೌದಿಲ್ಲ? ಇದಕ್ಕೆ ನಾ ಏನ್ ಕಲಿಸೋದೈತಿ? ಕರೆ ಹೇಳ, ನಾ ಏನ್ ಕಲಿಸ್ಬೇಕು? ನೀವು ಯೋಚನೆ ಮಾಡ್ತಿರ್ ಬರ್ತದಲ್ಲ, ನಾವು ಯಾಕೆ ವಿಚಾರ ಮಾಡೋದು ಸರ್? ಅದು ಮಾಸ್ತರ್ ಕೆಲಸ ವಿಚಾರ ಮಾಡಿ. ಮಾಸ್ತರ್ ವಿಚಾರ ಮಾಡಿ ನಮ್ಗೆ ಹೇಳ್ರಿ, ನಾವು ಬೇಕಾದ್ರೆ ಕೇಳ್ತೀವಿ. ನಮ್ಗೆ ತಿಳಿದಿಲ್ಲ ಇನ್ನೊಮ್ಮೆ ಕೇಳ್ತೇವೆ, ಇನ್ನೊಮ್ಮೆ ಹೇಳ್ರಿ. ನಿಮ್ ಕೆಲಸ ಅದ ಅಂದ್ರೆ ದನ ಕಾಯ್ಬೇಕು. ಈಗ ನೋಡಿ, ನಾನು ನಿಮ್ಗೆ ಸಾಕಷ್ಟು ಕಲ್ಸೇನಿ ಫಿಸಿಕ್ಸ್. ಈಗ ನೀವು ಅಲರ್ಟ್ ಆದ್ರೆ ಬರೋಬ್ಬರಿ ಆನ್ಸರ್ ಮಾಡ್ತೀರಿ. ಸಣ್ಣ ಹುಡುಗರ ಜೊತೆ ಕ್ಲಾಸ್ನಾಗ ಕೂತ್ರೆ ಇಷ್ಟ ಹಣೆ. ಹೌದಿಲ್ಲ? ಈಗ ನಾ ಹೇಳ್ಕೊಡ್ಲಿಲ್ಲ, ಈಗ ಮಜಾ ನೋಡ್ರಿ. ಈಗ ಆನ್ಸರ್ಸ್ ನಾ ಹೇಳಾಕತ್ತಿಲ್ಲ, ನೀವೋ ಯಾರ ಹೇಳಾಕತ್ತೀರಿ. ಒಬ್ರು ಯಾರು ಈಗ ಋತ್ವಿಕ್ ಹೇಳಿದ, ಆಗಲಿ ಈಕಿ ಹೇಳಿದ್ರಿ, ಆಗಲ್ಲ ಇವ ಹೇಳಿದ. ಹಂಗೆ ನೀವೇ ಹೇಳಕ್ ಬರ್ತೈತಿ. ಫಿಸಿಕ್ಸ್ ಕಲ್ಸೋದ್ ಬೇಕಾಗಿಲ್ಲ, ಖರೆ ಹೇಳ್ಕೊಡ್ರಿ. ನಾ ಬರೇ ನಿಮ್ಗೆ ಕ್ವಶನ್ ಕೇಳ್ತೀನಿ, ನೀವು ಆನ್ಸರ್ ಹೇಳ್ಬೋದು. ನೀವು ಕಾಮನ್ ಸೆನ್ಸ್ ಯೂಸ್ ಮಾಡ್ರಿ, ಸೈನ್ಸ್ ಟರ್ಮ್ಸ್ ಯೂಸ್ ಮಾಡ್ರಿ, ಅಷ್ಟ ಮುಗೀತು. ಈಗ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಈ ಬಾಡಿಗೆ ಏನೇನಾಗ್ತೈತಪ್ಪ? ಹೌದಿಲ್ಲ? ಗುಡ್, ವೆರಿ ಗುಡ್. ಈಗ ಒನ್ ಬೈ ಒನ್ ಬರೋ. ಈಗ ಐ ಅಪ್ಲೈ ಫೋರ್ಸ್ ಟು ದಿಸ್ ಬಾಡಿ, only speed will change. Means what?
Sir, the force is acting along with.
Good.
Along with the straight line.
Yeah, along. The force is acting along. The force is acting along the line passing through the velocity vector. Understood? See, this is a line passing through the velocity vector. The force is acting along this line. Force is acting along this line means either it is acting like this or it is acting like this. That's all. Only then speed will change. Got it?
Yes, sir.
Very good. So for first condition, the force vector must be collinear with the velocity vector. For the first condition, ಏನಂದೇನ ಈಗ? Collinear. Collinear ಅಂದ್ರೆ along that line. ಅನುಮಾನ ನೋಡೋಣ.
Collinear.
ಅಷ್ಟೇ. If the force vector is collinear with the velocity vector, only speed will change. If it is in the same direction, speed will increase. If it is in the opposite direction, speed will decrease. Simple common sense. ಏನು ಬೇಕು ಇದಕ್ಕೆ? ಏನು ಬೇಕಾಗಿಲ್ಲ. ಧೈರ್ಯ ಬೇಕಾ? ಧೈರ್ಯ ಆಯ್ತು ಬನ್ನಿ, ಏನಿಲ್ಲ ಅಂತಲ್ಲ. ನಾ ಕ್ಲಾಸಿಂದ ಹೊರಗೋದು ಮಸ್ತ್ ಧೈರ್ಯ ಬರ್ತೈತಿ. ನಾ ಇದ್ರಷ್ಟು ಸುಮ್ ಕೂಡ್ತೀನಿ ಅಷ್ಟೇ, ಹೌದಿಲ್ಲ? ಇರಲಿ, ಆನ್ಸರ್ ಮಾಡ್ತೀರಿ. ಹಾಂ, ಸೊ force vector is collinear with the velocity vector, then speed will change. Correct?
Yes, sir.
Only direction should change.
Sir, the force.
Speed should not change. Only direction should change. Only direction should change. Speed should not change. Then what should you do? You go body in one direction.
So
Imagine.
the force must be in that direction.
ಯಾವ ಡೈರೆಕ್ಷನ್?
So now
ನೋಡಿ
we
ನೋಡಿ
are
ಕೇಳಿ,
changing.
ಈಗ ಬಾಡಿ ಹೊಂಟದ, ಕಾಣಿಸ್ತದ?
Yes, sir.
ಹಾ, ಈಗ if I apply force collinear like this or like this, then only speed will change.
Yes, sir.
Now I want you should tell me how I should apply force such that only direction will change.
Sir, body what the
Very good. ನೋಡ, ಕಾಮನ್ ಸೆನ್ಸ್ ಯೂಸ್ ಮಾಡಿದವ. ಬಾಡಿ ಹಿಂಗ್ ಹೊಂಟ್ರ ಹಿಂಗ್ ಅಪ್ಲೈ ಮಾಡ್ರಿ ಫೋರ್ಸ್. ಅವಾಗ ಬರೇ ಏನಾಗ್ತದೆ? ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್. ಯಾರು ಹೇಳ್ಕೊಟ್ರಪ್ಪ ಇದು ನಿಮ್ಗೆ? ಖರೆ ಹೇಳಿ, ಯಾರು ಹೇಳ್ಕೊಟ್ರು?
ಇಲ್ಲ sir.
ಯಾರು ಹೇಳ್ಕೊಟ್ಟಿಲ್ಲ. ಮತ್ತೆ ಹೆಂಗ್ ಹೇಳಿದ್ದಿ ಇದನ್ನ?
Sir,
ವಿಚಾರ ಮಾಡಿದ್ರೆ ಬಂತು. ಕರೆಕ್ಟ್, ಪರ್ಫೆಕ್ಟ್ ಆನ್ಸರ್, ಪರ್ಫೆಕ್ಟ್ ಆನ್ಸರ್. ನೋಡ, ಈಗ ಬಾಡಿದ ನೋಡಿ ಇಷ್ಟ ಫಿಸಿಕ್ಸ್ ನಾ ಏನ್ ಹೇಳ್ಕೊಟ್ಟೆ ಅಂತ ಹೇಳಿ, ನಾವು ಒಂದು ಒಮ್ಮೆ ಕಲ್ಸಿದ್ದೀನಿ. ನೋಡ, ಈಗ ನೋಡಿದೆ, the body's velocity vector is like this. I gave the condition only direction should change. This boy used this common sense and he said, sir, the force vector must be perpendicular to the velocity vector. If the force vector is perpendicular to the velocity vector, then what will happen? At that instant, see here, please appreciate. When I say force vector is acting means only akshana, only at that instant the force vector is acting. It is not that force is acting. Understood? Now, see, understand. See, I am making this sound so that you will see. For physics teacher, he can dance, he can sing, he can use sound. What the truth here? See, you go to movies now, they will put different color clothes, they will dance, they will sing. Why? Because they want to communicate the feeling. Here also I am doing the same thing. So when I show like this, what does it mean? These are the vectors at an instant of time. These are the vectors at an instant of time. Got it?
Yes, sir. Yes, sir.
That is what it means. Unless otherwise stated. Unless otherwise stated. Unless otherwise andra bare condition hakidra, oh, force is acting for so much time. Velocity is there for so much time. I should tell explicitly. If I don't tell, it is understood. ಈಗ ನಿಮ್ಗೆ ಯಾರ ಮನೆಗೆ ಊಟಕ್ಕೆ ಬರ್ರಿ ಮನೆಗೆ ಅಂತ ಕರೀತಾರೆ. ನಮ್ಮ ಮನೆಗೆ you come for lunch. So you will go for lunch. So today's the lunch is very good. We are serving sweets. Okay, khara, this and then sandigi is there, all this there. Okay, fine. Oh, fine, will come. So you go there for the lunch. Okay, then you ask for water. No, we didn't tell we'll give you water. It is understood, no? Ardadala. So unless otherwise told, water is served along with the lunch. Hanga ille. If that means now all these things are happening at an instant of time. If I explicitly tell that this is the condition during this time interval, then you should include the time interval. Got it now? Hello? Very good. I am so happy that you answered. My life is very easy now. So if the force vector is perpendicular to velocity vector, only direction will change. If the force vector is collinear, then only speed will change. ತಿಳಿತಾ? ಈಗ ಎಲ್ಲರೂ ಥಿಂಕ್ ಮಾಡ್ರಿ, ಯಾರು ಆನ್ಸರ್ ಮಾಡಬೇಡ್ರಿ. ನಾ ಯಾರು ಆನ್ಸರ್ ಮಾಡ್ತೀವಿ ಅವರ ಮಾಡ್ಬೇಕು. I will give 3 minutes time to think. Right? Okay. Now there is a body. Its velocity vector is v bar. Now you should apply force to this body such that both its direction and speed will change. There is velocity vector attached to the body of mass m. Now, how will you apply force to this body such that both its speed and direction will change? Think for 2 minutes. Speed and direction to change. What should I do?
Sir,
If you don't answer, I will make you to stand up on the bench. Ready to take the challenge? Until.
sir, force perpendicular or sir.
So you will say force should be perpendicular.
But the ಇನ್ನೊಂದು force
Innocent force, but one more force should be collinear.
But human, sir.
So in this condition, body's speed and direction both will change.
Yes.
That's what you told.
Yes.
Another way,
Other direction like this.
other direction means any direction.
Yes.
Force can be in any direction.
I'm asking the equals, sir. For that.
Force can be in any direction. Do we agree, all of you? Is he right? Shall I make him to stand up on the bench or no? Is he right?
Yes, sir.
He is right.
Yes.
Why do you say he is right? Come on, be brave now. It is all open to all of you. Why do you say he is right? What makes you think he is telling the right answer? Yes, Rutvik and so on. You also. He told.
Yes, sir.
He told you apply one force like this and another force like this, then speed and direction will change. And then he told the second answer, sir, apply the force yatra patra means any direction with the velocity vector. Then also both will change. Is he right or wrong?
Sir, second one wrong.
Second one wrong anastheti. Huh?
So first one correct.
Sir,
First one is correct. Why you say it is correct?
Sir, because ಅಲ್ಲಿ F1 F2 minus F1 ಮಾಡಿದ್ರೆ net force ಇದು ಬರ್ತದೆ.
F2 minus F1 ಮಾಡಿದ್ರೆ
So net force 0 ಆಗೋದಿಲ್ಲ. So force ಈ ಕಡೆ ಹೋಗ್ತೈತಿ.
F2 minus F1 ಮಾಡಬೇಕಾ? F2 minus F1 ಮಾಡಿದ್ರೆ ಏನಾಗ್ತದೆ?
So net force.
Net force ಬರ್ತದೆ.
So sir force ಈ direction ಆಗಿ ಹೋಗ್ತೈತಿ. ಮತ್ತೆ speed change ಆಗ್ತದೆ.
ಹಂಗಂತಿ. ಓಕೆ, ಇನ್ಯಾರು ಅಗ್ರಿ ಮಾಡ್ತೀರಪ್ಪ ಫಸ್ಟ್ ಕಂಡೀಷನ್ಗೆ? Sohan, Rutvik, do you agree?
Yes, sir.
Why do you
Yes, sir.
think the first answer is right?
Sir, because one time you had always told, sir, to change the force of speed and the direction, there should be another force to apply on the body.
ಏನ್ ಹೇಳಿದ್ಯೋ ಬರೋಬ್ಬರಿ ಹೇಳು, ಸಾವಕಾಶ ಹೇಳು.
Sir,
You said that if to change the velocity of a body, another force should act.
ಅಲ್ಲೋ ಇದ್ಯಾಕೆ ಎರಡು ಫೋರ್ಸ್ ಏನ್ ಮಾಡ್ತಿದ್ವಿ? ಇಲ್ಲಿ ಎರಡು ಫೋರ್ಸ್ ಏನ್ ಮಾಡ್ತಿದ್ವಿ? ಇಲ್ಲಿ ಎರಡು ಫೋರ್ಸ್ ಏನ್ ಮಾಡ್ತಿದ್ವಿ? ಎರಡು ಫೋರ್ಸ್ ಯಾಕೆ ಕೊಟ್ಟವ?
ಸರ್ ನಂಗೆ ಒಂದೇ ಕ್ವಶನ್ ಆನ್ಸರ್ ಬಂತು.
ಇದು ಯಾಕೆ ಎರಡು ಫೋರ್ಸ್? ಇದು ರೈಟ್ ಆರ್ ರಾಂಗ್ ಹೇಳ. Now he will only explain on what basis did you tell this answer.
Sir, ಅದು first ಹಿಂಗ್ straight ಹೋಗೋ ಒಂದು collinear attach ಮಾಡಿ speed change ಮಾಡ್ತೀವಿ.
So he is telling that if you give this force, because it is collinear, it will alter the speed.
Yes.
So that is why he added one force. Next.
Sir, perpendicular and ಕೊಟ್ಟರೆ direction change.
Correct. Simple. This is simple logic, isn't it? The force which is in perpendicular direction will only change the direction. The force which is collinear will change the speed, and when both acts, both will change. Simple logic here. Hats off to you. Hats off to you. Hats off to you. In my career of 32 years, there are 9 to 10 students who answered like this at this high school level. That's why I am trying you. Physics is not difficult. ಈಗ ನೋಡಿ ನಾನು ಇಷ್ಟು ವೆಕ್ಟರ್ಸ್ ಕಲಿಸ್ಬಿಟ್ಟೇನೆ, ಇಷ್ಟ ಸಾಕು. ಇನ್ನು ಮುಂದೆ ಎಲ್ಲ ನೀನ ಕಲಿಯಕ್ಕೆ ಬರ್ತೈತಿ. That is the power of learning physics properly. ಈ ಪುಸ್ತಕವಾಗಿ ಬಯಾಟ್ ಮಾಡಿದ್ರೆ ಏನು ಮಾಡ್ತಿದ್ದಿ? ಏನು ಅಂತ ಟೀಚರ್ ಹೇಳಿ ಬರ್ತೀವಿ. ಈಗ ನೋಡಿ ನೀನ ಬರಿಬೋದು. He is perfectly correct. And this is common sense now. Come on, see, now your own friend has answered. And what did he do? He used logic. His logic was simple. A force which is collinear will change the speed. A force which is perpendicular will change the direction. If both acts, then both will change. Very simple logic. Excellent. Excellent friend. Now, my dear friend here, Harshita, was telling something about net force. Okay? Now this force is acting, this force is acting. What is the net force of these two? How did I tell you to calculate, to find net force?
So we have to draw the parallel.
That's it. Good. I like this. I like this gesture. Oh, sorry, sir. See, there is confidence in you today. Keep it up. Very good. This is all I want. Don't worry. If you are not expected to give 100% correct answer like how we give. You give, sir. That is it. Sir, sorry, sir. You understood your mistake now. My job is done. My job is done. My job is to make you feel, yes, this is the mistake. And you know how to correct it. I don't have to tell. Come on now, tell me. What is the resultant here? Net force?
So we have to draw a line.
Yes, you draw a line which is parallel to this and another line which is parallel to this. And then this becomes what? The resultant force or the net force. Correct?
Yes, yes.
So you told no yatra patra you add. So that means instead of adding this force and this force, if you had added this force, then both speed and velocity would have changed. Speed and direction would have changed. Got it?
Yes, sir.
Hello, did you all get it?
Yes, sir.
Hey, Sohan, Rutvik. Sohan and Rutvik, are you there?
Yes, sir.
Did you understand?
Yes, sir.
So what is this called? This is called resultant. Resultant of the two forces. Resultant of F1 bar, resultant of F1 bar and F2 bar. This plus andre arithmetic plus alla. It's called vectorial plus. See, this is 10 Newton, this is 10 Newton. What is this net force? This is not 10 Newtons. It is 10 root 2 Newtons in that direction. The value of this force will be 10 root 2 Newtons in that. Pythagoras theorem. 10 plus 10. Pythagoras theorem. A plus B. What is this C? C is equal to root of A square plus B square. You will get 10 root 2. So the magnitude of the force 10 root 2 if you apply, and if it makes an angle 45 degrees, then the effect of this in this direction is 10 Newtons. The effect of this in this direction is 10 Newtons. So this effect may change the speed, and this effect will change the direction. Together, it will change both speed and direction. Hats off. Today I am very, very happy. I will sleep very nicely. Today I am seeing she is answering, he is answering, you are answering, everybody. Only you are not answering. You also start answering. I will be very, very happy. Okay? It's a day to celebrate. Fantastic. Understood, students? See, now understand, vectors are in. So, we are able to express the truth of motion, okay, in such a manner that whatever I feel in my heart, I can convey it like that to you. And whatever is there in your heart, you can convey it to me, thanks to this. And today, I have not taught anything, I have only asked questions and you have answered. There is nothing extra I have taught today. Is that clear to all of you? Hello?
Yes, sir.
Clear? Great. See students, some of you, they have drawn a circle. I hope all of you have seen this. Okay? And then they have told that a body is moving along the circle. They have told a body is moving along the circle with some speed v. Right? They have shown one circle with this somewhere. Open close first. That they had drawn one body with circle with something like this. See here, hello. So they have shown like this. They have shown like this. That the other day I told no.
Yes, sir.
They have shown like this. They have shown somewhere. I don't know. Forget. So a body is moving in a circular path. See, for example, now you tie a stone to a thread. One darakon kal katti hinga tirgishidre. Hello.
Yes, sir.
That dara will rotate. Hello, Madidilla.
Yes, sir.
So you tie a stone to a thread and do like this. That dara will rotate, go in a circular path. Will it go?
Yes, sir.
Yes, sir.
It is going in a circular path. Correct? Now you think very carefully. So when the body is here, what is the velocity of the body? V1 bar. Correct now? I told you it is tangential to the path. Do you understand this?
Yes, sir.
When the body travels like this and comes here, its velocity vector will be V2 bar here. You remember I already taught you this.
Yes, sir.
And when the body is here, its velocity becomes V3 bar. And when the body is here, its velocity is V4 bar. And when the body here is V5 bar, V6 bar, like this. This diagram is there in the book. So here you see the body is moving in circular path, but its velocity vector is changing. Can you see? This velocity vector, see, the speed is same. That means the magnitude of the velocity vector is same. But its direction is continuously changing. Hello?
Yes,
Yes,
sir.
sir.
Do you appreciate?
Yes, sir.
So this is called uniform circular motion. Uniform circular motion. And the uniform means speed is same and it is moving in circular path. Uniform circular motion का मतलब क्या है? Speed is same but and it is moving in circular path. So it is moving in circular path with same speed, uniform speed. You see, got it? Now, if you look at that body in terms of velocity, in terms of motion, then you will attach a velocity vector to the body. So this is what I have done. And now if you analyze this, you see that the velocity vector is continuously changing.
Yes, sir.
And how is it changing? Only the direction is changing. Only the direction is changing. ನೀವು ಒಂದೇನ್ ಮಾಡಿದ್ರಿ, ನೀವು ಹಿಂಗೆ ನಿಂತೀರಿ, ರೈಟ್? ಅಂಡ್ ನಿಮ್ಮ ಕೈಯಾಗ ಒಂದು ದಾರ ನಿಮ್ಮ ಕೈ ಸರಿ, ನಿಮ್ಮ ಕೈಗೆ ಒಂದು ದಾರ, ಥ್ರೆಡ್ ಟು ಯರ್ ಹ್ಯಾಂಡ್, ಅಂಡ್ ದೆನ್ ಇಟ್ ಇಸ್ rotated. How is this velocity vector changing? Because velocity vector change ಆಗಬೇಕಂದ್ರೆ ಏನು ಬೇಕಪ್ಪ? ಏ ದನ ಫೋರ್ಸ್ ಹೌದಿಲ್ಲ? velocity vector change ಆಗ್ಲಿಕ್ಕೆ ಏನು ಬೇಕು? What do you need to what is necessary to change the velocity vector? Speed. Only force. Only force can change the velocity vector, no? It is on that basis only we are discussing, no? ಹೌದಿಲ್ಲ? ನಾನು ನೀನು ಯಾಕೆ ಮಾತಾಡಕತ್ತೀವಿ? ಮನುಷ್ಯರ ಅಂತ ಹೇಳಿ, ಹೌದಿಲ್ಲ? ಹಂಗ ಬೇಸಿಕಲಿ ಈ velocity vector has to change, only speed will change. One minute. Only then force is necessary. Here, what is changing? Velocity vector is changing. What of the velocity vector is changing? Only direction is changing. That means there must be force acting. Where is the force acting? To this body, who is applying the force? ನಿನ್ನ ಕೈ ಇಲ್ಲೈತಿ, ಬಾಡಿ ಇಲ್ಲೈತಿ. ನಿನ್ನ ಕೈ ಇಲ್ಲೈತಿ, ಬಾಡಿ ಇಲ್ಲೈತಿ. ನಿನ್ನ ಕೈ ಮತ್ತು ಬಾಡಿ ನಡಕ್ಕೆ ಏನೈತಿ? ದಾರ. ನಿನ್ನ ಕೈ ಮತ್ತು ಬಾಡಿ ನಡಕ್ಕೆ ಏನೈತಿ? ದಾರ. Dara is applying the force. The tension in the thread is applying the force. And how is the tension? It will be perpendicular. ಇಲ್ಲಿದ್ದಾಗ ದಾರ ಇಲ್ಲಿರ್ತೈತಿ, ಇಲ್ಲಿದ್ದಾಗ ದಾರ ಇಲ್ಲಿರ್ತೈತಿ, ಇಲ್ಲಿದ್ದಾಗ ದಾರ ಇಲ್ಲಿರ್ತೈತಿ, ಇಲ್ಲಿದ್ದಾಗ ದಾರ ಇಲ್ಲಿರ್ತೈತಿ, ಇಲ್ಲಿದ್ದಾಗ ದಾರ ಇಲ್ಲಿರ್ತೈತಿ. ಇಲ್ಲಿ ನೋಡ್ಬೇಕಾದ್ರೆ ಯಾವಾಗಲೂ ದಾರ ಮತ್ತು ಇದು perpendicular. Understood all of you? I'll continue in the next class. Right? Understood now? Now you also should start answering. Everybody are answering now except you. You also answer. This class will be the greatest class in the world.